Imagine a tiny spacecraft launched nearly half a century ago, drifting silently through the vast emptiness of space, far beyond the reach of our solar system. This is Voyager 1, humanity's farthest reaching emissary, now over 15 billion miles from Earth, floating in the uncharted waters of interstellar space. On Thursday, July 24th, 2025, NASA announced a discovery that has sent shockwaves through the scientific community and ignited the imaginations of people worldwide. Voyager 1, the first human-made object to venture between the stars, detected something extraordinary, something moving nearby. This isn't just another data point from a distant probe. It's a moment that challenges our understanding of the universe and raises profound questions about what lies beyond. Join us as we unravel this cosmic mystery, explore its implications, and ponder what it means for humanity's place in the galaxy. Stick with us to the end, because this story is unlike anything you've heard before. Voyager 1's journey began in 1977, a time when disco ruled the airwaves and computers were the size of rooms. Designed to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune, it was never meant to venture this far. Yet, after completing its primary mission, Voyager 1 kept going, powered by a small nuclear generator and a relentless human drive to explore. In 2012, it crossed the heliopause, the boundary where the sun's influence fades, and entered interstellar space. A region where the sun appears as just another faint star in an endless sea of darkness. For nearly 5 decades, this 800-pound relic of early space exploration has been humanity's lone sentinel in the void, sending back faint signals across billions of miles with a transmitter no more powerful than a refrigerator light bulb. Interstellar space is a strange and lonely place. It's not completely empty, but it's sparse, filled with a thin soup of charged particles, magnetic fields, and cosmic rays. Here, the rules of physics we know from our solar system don't always apply. Voyager 1's instruments, though aging and limited, have been quietly measuring this alien environment, painting a picture of a realm we've never seen up close. But recently, something disrupted that quiet drift. Something passed near Voyager 1, leaving a trace in the data that has scientists scrambling to understand what it could mean. This wasn't a random blip or a glitch. It was a deliberate rhythmic signal suggesting movement, precision, and perhaps even intention. The discovery began subtly, as most profound moments do. Voyager 1's plasma wave instrument, one of the few sensors still operational after decades of wear, picked up a peculiar disturbance in the interstellar medium. This instrument is designed to measure changes in the density of charged particles, the plasma that fills the space between stars. Normally, it records a low hum of cosmic activity, random fluctuations caused by solar winds, cosmic rays, or distant galactic events. But this time, the data was different. Instead of the usual chaotic hiss, Voyager detected a smooth, sustained pattern, like ripples spreading across a still pond. For several hours, the plasma density fluctuated in a way that suggested something physical was displacing the particles around it. The signal was narrow, precise, and symmetrical, decaying in a controlled oscillation that hinted at a compact object moving at incredible speed. Coupled with this was a faint shift in the surrounding magnetic field, detected by Voyager's magnetometer, which briefly deviated before returning to normal. This wasn't the chaotic signature of a solar flare or a cosmic ray burst. It was something else. Something that didn't match any known phenomenon in NASA's extensive catalogs. Scientists at NASA's Jet Propulsion Laboratory in Pasadena, California, were stunned. They combed through the data, running diagnostics to rule out errors. Voyager 1's systems, though old, were functioning as expected. There were no signs of software glitches, telemetry corruption, or instrument failure. The data was clean, and the event was real. Whatever caused this disturbance had passed close enough to Voyager 1 to leave a measurable trace, yet it remained invisible to the probe's long-dormant optical systems, which can no longer capture images. This was a ghost in the machine, a shadow moving through the darkness, detected only by the ripples it left behind. The question on everyone's mind is, what could this be? The data offers tantalizing clues, but no definitive answers. Analysis suggests the object was small, perhaps no larger than a car, but moving at a velocity far greater than typical interstellar dust or meteoroids. Its speed and trajectory didn't align with the ballistic paths of natural objects like comets or planetary fragments. Instead, the data hinted at a deliberate course, a path that seemed to adjust subtly as it passed, almost as if it had made a correction to avoid Voyager or to align with some unseen destination. This course correction is what has scientists buzzing. Natural objects don't behave this way. A rock or dust grain hurtling through space follows a predictable trajectory shaped by gravity and momentum. But this object appeared to respond to its environment, navigating the interstellar medium with a precision that defies easy explanation. Some researchers have proposed exotic natural causes, like a fragment propelled by a plasma sail, a hypothetical mechanism where an object harnesses the weak flow of interstellar ions to glide through space. Others suggest it could be a rogue shard from a distant star system, ejected by a violent stellar event and caught in an unusual magnetic anomaly. But there's another possibility, one that's both thrilling and unsettling. Could this be an artificial object, a probe, or artifact from another civilization? The idea seems like science fiction, but the data doesn't rule it out. The object's lack of reflective properties, its apparent ability to absorb rather than scatter energy, suggests a material far beyond our current technology. Its silence, the absence of any detectable emissions or propulsion signatures, implies a level of stealth and efficiency we can barely imagine. If this was a machine, it was designed to move unnoticed, slipping through the galaxy like a whisper. The detection has sparked a frenzy of activity in the scientific community. At universities and research institutions around the world, teams are poring over Voyager's data, feeding it into supercomputers to simulate the event. Early models suggest the object's path was highly controlled, interacting with the interstellar medium in ways that hint at advanced physics. One theory being explored is magnetohydrodynamic propulsion, a method where an object manipulates magnetic fields and ionized particles to propel itself without conventional engines. Such a system would be nearly invisible, leaving only subtle disturbances like those Voyager recorded. Another line of inquiry focuses on the interstellar medium itself. Our current models describe it as a sparse, uniform environment, but what if it's more structured than we think? Could there be evidence of invisible currents, magnetic filaments, or plasma channels that guide objects through space? If so, Voyager may have stumbled into one of these cosmic highways, a pathway used by something else traveling with purpose. This idea challenges the notion of space as a passive void, and suggests a universe alive with hidden patterns and dynamics we've yet to map. The event has also prompted a reevaluation of how we observe the cosmos. Most of our knowledge relies on electromagnetic signals, light, radio waves, X-rays, but this object betrayed its presence through physical displacement, a tactile interaction with its environment. This has led to calls for new types of detectors, ones that can sense ripples in plasma, shifts in magnetic fields, or even minute changes in quantum states. These tools would act less like telescopes and more like cosmic skins, feeling the universe rather than seeing it. Such a shift could redefine astronomy, opening our eyes to phenomena we've been blind to until now. The Voyager 1 encounter has exposed significant gaps in our ability to detect and interpret events in interstellar space, pushing the boundaries of current technology and inspiring a wave of innovation. Detecting an object through plasma displacement rather than light or radiation presents unique challenges, as it requires instruments sensitive to subtle, transient changes in an environment we barely understand. Voyager's plasma wave instrument, a relatively simple device by today's standards, was able to capture this event precisely because of its unfiltered sensitivity, but modern spacecraft often prioritize high-resolution data over raw, open-ended observation. This has led engineers to rethink spacecraft design, proposing hybrid systems that combine advanced sensors with robust, low-tech components to maximize the chances of catching rare anomalies. Developing such instruments is no small feat. Interstellar space is a harsh environment with extreme cold, cosmic radiation, and vast distances that demand unparalleled durability and precision. For instance, creating a plasma sensor capable of resolving micro disturbances over decades requires materials that can withstand degradation and electronics that remain stable without maintenance. Furthermore, the data transmission challenge is immense. Voyager's 23-watt transmitter takes over 22 hours to send a signal to Earth, and future probes will need to communicate across even greater distances with limited power. Scientists are exploring solutions like laser-based communication systems or AI-driven data compression to prioritize significant anomalies, but these technologies are still in their infancy. The encounter also underscores the need for distributed sensor networks, arrays of small, cost-effective probes scattered across interstellar space to increase the odds of detecting similar events. Such a network would require international collaboration and funding on a scale not yet seen, as well as breakthroughs in autonomous navigation to ensure probes can operate independently for centuries. The technological hurdles are daunting, but they represent an opportunity to push human ingenuity to new heights, driven by the tantalizing possibility that more such encounters await us in the cosmic dark. The Voyager 1 detection has opened a Pandora's box of possibilities for astrophysics, suggesting that the interstellar medium may be far more dynamic and complex than previously thought. The object's interaction with the plasma and magnetic fields hints at the existence of structured phenomena, perhaps magnetic filaments, plasma vortices, or even dark matter interactions that could govern motion in ways we don't yet understand. These cosmic currents might act like interstellar trade winds, guiding objects along paths of least resistance, much like ocean currents shape maritime routes on Earth. If such structures exist, they could explain the object's precise trajectory and open a new field of study focused on mapping the invisible architecture of the galaxy. For example, the symmetrical oscillation in Voyager's data suggests a localized field interaction, possibly a magnetic anomaly or a plasma density gradient that influence the object's path. This challenges the standard model of the interstellar medium as a homogeneous, low-density environment and raises questions about whether unseen forces, gravitational, electromagnetic, or even quantum, play a larger role in interstellar dynamics. Researchers are now using supercomputer simulations to model these hypothetical structures, drawing on Voyager's data to test scenarios involving magnetic reconnection events, ion streamlines, or even speculative phenomena like axion fields. If confirmed, these discoveries could rewrite our understanding of how matter and energy move through the galaxy, with implications for everything from star formation to the propagation of cosmic rays. Moreover, the event suggests that interstellar space may host a variety of transient phenomena, rogue objects, exotic particles, or even undiscovered forms of matter that only become visible through their interactions with probes like Voyager. This has sparked proposals for missions dedicated to plasma cartography, aiming to chart the subtle variations in the interstellar medium with unprecedented detail. Such missions could reveal a galaxy alive with hidden pathways and interactions, transforming our view of the cosmos from a static void to a vibrant interconnected web. The Voyager 1 encounter has prompted a fundamental rethinking of space exploration strategies, shifting the focus from targeted, short-term missions to long-term, adaptive approaches designed to capture the unexpected. Traditionally, space missions have been tightly scoped, with specific objectives like studying a planet or mapping a star system, but Voyager's detection of an unpredicted phenomenon underscores the value of open-ended exploration. The event suggests that the interstellar medium is not a passive backdrop, but a dynamic environment where rare, fleeting events can occur, requiring a new breed of missions that prioritize longevity, flexibility, and sensitivity to subtle anomalies. Scientists are now advocating for the development of sentinel fleets, networks of small, durable probes deployed across vast regions of space, each equipped with multimodal sensors to detect plasma disturbances, magnetic fluctuations, and other non-electromagnetic signals. These probes would operate on minimal power, designed to function for centuries, much like Voyager, but with modern advancements like quantum sensors and AI-driven anomaly detection to identify patterns that might elude human analysts. Such a strategy would require a paradigm shift in mission planning, moving away from high-cost, high-profile launches toward distributed, cost-effective systems that maximize coverage and resilience. The encounter has also revived interest in modular spacecraft designs, where components can be upgraded or reconfigured remotely to adapt to new discoveries, ensuring that probes remain relevant even as our understanding of the cosmos evolves. Funding such ambitious projects poses a challenge, as space agencies must balance public expectations for immediate results with the long-term value of passive observation. Yet, the potential rewards, uncovering new phenomena, mapping interstellar currents, or even confirming the presence of artificial objects, make this shift a compelling investment. By embracing a strategy of patient, pervasive exploration, humanity could transform its approach to the cosmos, turning space into a laboratory where the unexpected becomes the cornerstone of discovery. The Voyager 1 encounter has catalyzed an unprecedented level of interdisciplinary collaboration, drawing together experts from fields as diverse as astrophysics, engineering, data science, philosophy, and even anthropology to grapple with its implications. The event's ambiguity, whether it was a natural phenomenon or an artificial object, demands a holistic approach that transcends traditional scientific boundaries. Astrophysicists are working with plasma physicists to model the object's interaction with the interstellar medium, while engineers engineers are partnering with materials scientists to design next-generation sensors capable of detecting similar disturbances. Data scientists are developing machine learning algorithms to sift through Voyager's raw data, searching for patterns that human analysts might miss, and collaborating with statisticians to assess the probability of such a rare event occurring by chance. Beyond the hard sciences, philosophers and ethicists are engaging with the question of what it means to encounter something potentially intelligent, exploring how humanity should respond if future detections confirm official origin. Anthropologists are studying the societal impact of the event, analyzing how different cultures interpret the possibility of an interstellar visitor and what it reveals about our collective hopes and fears. This cross-pollination of ideas has led to innovative frameworks, such as the proposal for a cosmic ecology model that views interstellar space as a complex ecosystem of interacting forces, objects, and possibly intelligences. International research consortia, including NASA, the European Space Agency, and emerging space programs in countries like India and China, are pooling resources to fund joint missions inspired by Voyager's discovery. These collaborations are not without challenges. Differing priorities, funding constraints, and geopolitical tensions complicate the effort, but the shared sense of urgency has fostered a spirit of unity rarely seen in global science. The encounter has become a rallying point, a reminder that the universe's mysteries are too vast for any one discipline or nation to tackle alone, and its legacy may lie as much in the bridges it builds on Earth as in the questions it raises about the stars. The Voyager 1 encounter has ignited a robust ethical debate about how humanity should proceed in investigating this and future interstellar anomalies, particularly if they hint at an artificial origin. If the object was a product of another intelligence, pursuing further detection efforts raises profound questions about our responsibilities as cosmic neighbors. Should we actively seek out such objects, potentially revealing our presence to an unknown civilization, or adopt a cautious approach, observing passively to avoid unintended consequences? Some argue that broadcasting signals or launching probes to intercept similar objects could provoke a response we're unprepared for, especially if the technology involved is vastly superior to ours. Others contend that the pursuit of knowledge is a moral imperative, and failing to investigate would betray humanity's curiosity and potential to connect with others in the cosmos. There's also the question of how to interpret the object's silence, its lack of communication or acknowledgement of Voyager. Was this a deliberate choice, suggesting a policy of non-interference, or simply a limitation of our detection methods? Ethicists are drawing parallels to historical encounters on Earth, where misunderstandings between cultures led to conflict, urging caution in how we approach a potential first contact. Additionally, the development of new detection technologies, such as plasma listening arrays, raises concerns about their dual-use potential. Could such systems be repurposed for military applications, escalating tensions on Earth? The global scientific community is grappling with how to balance transparency, ensuring that findings are shared openly, with the need to manage public reactions, which could range from awe to panic. Proposals are emerging for an international ethical framework to guide interstellar exploration, similar to protocols for handling extraterrestrial microbes, emphasizing precaution, collaboration, and respect for the unknown. These discussions are not just about science, but about who we want to be as a species, curious explorers or prudent observers, and how our choices will reflect our values in the vast, silent theater of the galaxy. The Voyager 1 encounter has had a profound psychological impact on the global scientific community, igniting a mix of exhilaration, humility, and existential introspection among researchers who have dedicated their careers to understanding the cosmos. For the scientists and engineers who have tended Voyager for decades, the event is a vindication of their perseverance, a testament to the enduring value of a mission launched when many of them were young or not yet born. Yet it also confronts them with the limits of human knowledge, as the object's ambiguous nature, neither clearly natural nor definitively artificial, challenges the frameworks they've spent lifetimes building. This tension has sparked a renewed sense of purpose, driving researchers to question long-held assumptions and embrace the uncertainty that the encounter represents. Some describe a feeling of standing on the edge of a new frontier, where every data point could upend decades of theory, while others grapple with the humbling realization that humanity's tools, even at their best, may only catch fleeting glimpses of a universe far more complex than imagined. The event has also fostered a sense of camaraderie, as scientists across disciplines share late-night discussions, virtual conferences, and collaborative papers, united by a shared sense of awe and urgency. For younger researchers, the encounter is a call to action, inspiring a new generation to pursue careers in astrophysics, engineering, and data science, driven by the possibility of unraveling this mystery. Yet there's also a quieter, more introspective undercurrent, the recognition that Voyager's discovery may be a one-time anomaly, a singular moment that defies replication, leaving scientists with the bittersweet task of extracting meaning from a fleeting signal. This psychological duality, excitement tempered by humility, has reinvigorated the scientific community, reminding them that the pursuit of knowledge is as much about embracing the unknown as it is about finding answers, and that Voyager's faint ripple from the void may be its most enduring gift to those who dare to dream beyond the stars. Beyond the science, the Voyager 1 encounter touches something deeper, our sense of place in the universe. For decades, we've wondered if we're alone, scanning the skies for signals from other civilizations. But what if the first evidence of intelligence isn't a radio broadcast, but a fleeting encounter in the dark? What if the galaxy is filled with silent travelers, moving unseen, their purpose is unknown? The idea that something may have passed near Voyager, perhaps noticing it, perhaps ignoring it, forces us to confront our own smallness and the vastness of the unknown. Voyager 1 carries the golden record, a time capsule of human culture with music, greetings, and images meant for anyone who might find it. The thought that something may have crossed paths with this message is profoundly poetic. Was it curious about our probe? Or was Voyager just another speck in its ancient journey? If the object was artificial, it suggests a civilization with technology far beyond ours, one that operates on timescales and principles we can't yet grasp. If it was natural, it hints at processes in the universe, perhaps even forms of life that defy our current understanding. This moment also challenges the Fermi paradox, the question of why we haven't seen signs of extraterrestrial life. Perhaps the answer isn't that no one's out there, but that they don't want to be seen. Maybe the galaxy is a quiet place, not because it's empty, but because its inhabitants move with stealth, observing without announcing themselves. Voyager's encounter could be a glimpse into this silent cosmos, a reminder that we're not the protagonists of the story, but bit players in a drama we barely understand. The Voyager 1 encounter has prompted a profound reevaluation of humanity's relationship with the cosmos, shifting our perspective from one of conquest to one of humility and interconnectedness. For much of our history, we've approached space as a frontier to be mastered, a resource to be exploited, or a stage for our own narrative. But this event suggests that the universe is not a blank canvas awaiting our mark. It is already alive with motion, with stories we have yet to read, and perhaps with actors who have been playing their parts for eons. The object's silent passage near Voyager challenges the anthropocentric view that we are the central figures in the cosmic drama, inviting us to see ourselves as part of a larger tapestry, where our role may be to listen and learn rather than to dominate. This shift has profound implications for how we approach space exploration, encouraging a philosophy of stewardship rather over ownership. It raises questions about how we should interact with the interstellar medium. Should we treat it as a pristine environment to be studied with care, or as a pathway to be navigated and utilized? The encounter also resonates with indigenous and philosophical perspectives that emphasize harmony with the natural world, suggesting that our cosmic journey might benefit from a similar ethos of respect and reciprocity. On a societal level, this moment has sparked a global conversation about what it means to be human in a universe that may be populated by others, whether they are intelligent machines, natural phenomena, or something entirely unknown. It has inspired calls for education reform to foster a cosmic literacy that equips future generations to navigate the complexities of interstellar exploration with wisdom and empathy. By redefining our place in the cosmos, Voyager's discovery is not just a scientific milestone, but a cultural and spiritual one, urging us to approach the stars with open hearts and curious minds, ready to embrace a universe that is far stranger and more wondrous than we ever imagined. Voyager 1's mission is nearing its end. Its power supply, a radioisotope thermoelectric generator, is slowly fading, and by the early 2030, it will fall silent, unable to send signals back to Earth. Yet even as it approaches its final years of us, it has delivered one last gift, a mystery that will outlive its creators. This encounter is a testament to the enduring power of exploration, a reminder that even a simple machine built with 1970s technology can touch the edge of the unknown. The data from this this event will fuel research for decades. Scientists are already designing new missions inspired by Voyager's discovery, probes equipped with advanced plasma sensors and magnetic field detectors to hunt for similar anomalies. These future explorers will build on Voyager's legacy, seeking to map the invisible currents of interstellar space and listen for the faint ripples of passing objects. Some propose launching deep patience probes, simple, long-lived spacecraft designed to drift and wait, capturing rare events over centuries. Voyager's encounter also highlights the value of simplicity. Its rudimentary instruments, unburdened by modern filters or algorithms, captured a signal that more advanced systems might have overlooked. This has inspired a dual approach for future missions: high-tech sensors for precision and low-tech components to catch the unexpected. Like an old vinyl record player picking up faint harmonics, Voyager's analog heart heard something the universe whispered. The Voyager 1 encounter has transcended the realm of science to become a global cultural phenomenon, capturing the imagination of people from all walks of life. News of the event has dominated headlines, sparked viral discussions on social media platforms like X, and inspired a wave of creative expression. Artists are painting cosmic scenes of ghostly objects gliding through starry voids, while musicians compose haunting melodies that echo the mystery of the unknown. Writers and filmmakers are crafting stories about humanity's first brush with an interstellar visitor, blending science with speculation to explore what it means to encounter something beyond our comprehension. This moment has rekindled a sense of wonder about the universe, reminding us that space is not just a frontier for scientists, but a canvas for dreamers. Schools are incorporating the event into curricula, using it to teach students about astrophysics, critical thinking, and the power of curiosity. Public interest in space exploration has surged, with organizations like NASA and the European Space Agency reporting increased engagement at virtual events and planetarium shows. Yet this discovery also carries a weight of existential reflection. People are grappling with the idea that we may not be the central figures in the cosmic narrative, a humbling shift that has sparked philosophical debates about humanity's role in the universe. Online forums are filled with discussions about whether we should actively seek out such phenomena or prepare for the possibility that we're already being observed. This cultural resonance underscores the encounter's power to unite humanity in shared awe and curiosity, proving that even a faint signal from 15 billion miles away can ripple through our collective consciousness, inspiring us to look up and wonder what else is out there. The detection has sparked a revolution in how we think about observing the universe. For centuries, astronomy has relied on light, photons carrying information across vast distances. But Voyager didn't see this object. It felt it through the subtle displacement of particles and fields. This suggests a new sensory modality, one that could complement our light-based tools. Imagine spacecraft that act like cosmic seismographs, measuring tremors in the interstellar medium to detect hidden movements. Such technology could transform our understanding of space. If the interstellar medium is filled with dynamic corridors, pathways shaped by magnetic fields or gravitational gradients, mapping them could reveal how objects, natural or artificial, navigate the galaxy. It might even allow us to harness these currents, sending probes along efficient routes with minimal energy. This would be akin to sailing the trade winds of the cosmos, a leap forward in our ability to explore. The implications for astrobiology are equally profound. If the object was artificial, it points to a form of intelligence that operates in ways we've barely considered: silent, efficient, and possibly ancient. If it was natural, it suggests exotic processes, perhaps even life forms that thrive in the interstellar void. Either way, Voyager's data is a clue in the grand puzzle of whether we're alone, a puzzle that grows more complex with every discovery. There's a certain poetry in Voyager 1's encounter. This aging spacecraft, a product of human ingenuity and hope, has reached into the darkness and felt something brush against it. That it happened now, as Voyager's voice grows faint, feels like the final verse of a cosmic sonnet. It's not an ending, but a beginning, a reminder that exploration is an eternal pursuit, driven by the questions we ask and the mysteries we chase. As Voyager drifts farther into the void, it carries our curiosity with it. Whether the object it detected was a natural wonder, an alien artifact, or something we can't yet name, its passing has left an indelible mark on our understanding of the cosmos. It's a signpost in the dark, whispering that space is not empty, but layered with motion, with stories, with possibilities. And as we ponder what Voyager felt, we're reminded that the universe is always ready to surprise us, not with fanfare, but with the faintest ripple, a gentle touch from the unknown that sets our hearts racing.